let's see, to give you some very concrete examples, I've encountered some really, really hard measurement problems, questions about the performance of a network or performance of a protocol or performance of a broadband access circuit. And I turn to people like Greg Chesson, who happens to work at Google. If he didn't work at Google, I would still turn to Greg. He's the inventor of XTP, which was an attempt to build a protocol that works better than TCP. And it actually did. It's just that it wasn't possible to get it out there because TCP was there and very heavily penetrated. But he's done some stunningly good work at Google in making things run a lot faster inside our data centers. So he's an example of someone. When it comes to understanding business models, which I don't understand very well, I'm just an engineer, I often will turn to Eric Schmidt or Hal Marion or Tame, the economist at Google. His email address is hal@google.com, and on his office is a big red dot. I don't know if you remember that from 2001. I also go outside of Google, so don't misunderstand. I picked some examples from inside. When it comes to understanding things like queuing theoretic models, underlying technical basis for understanding complex systems, Len Kleinrock is a guy I go to at UCLA because he has this amazing intuitive way of extracting the right model that can be analyzed, something that gives you a result that gives you a better sense or a quantitative sense for how things are going to behave. When it comes to climate questions and things like that, Al Gore turns out to be an incredibly good source. And if he doesn't know, he knows who knows. I'll give you a concrete example. I got nervous when I realized that the warming problem is not just a question of CO2. That's causing a lot of the problem right now. It's increasing the atmospheric temperature, it's increasing the acidity of the ocean. It is potentially raising the temperature of the ocean. But that's just the immediate problem. The scary part is the nonlinear part. The nonlinear part is the stuff that's down at the bottom of the ocean. It's methane hydrates. The methane hydrates are capturing in a kind of quasi-frozen form a huge amount of methane gas. And why is methane gas so scary? Well, it smells bad, but the thing that's most scary about it is that it's something like 37 times more effective as a global warming component of the atmosphere. And if it is released from the ocean, it's all over, game over. It happened about 55 million years ago that there was sufficient atmospheric warming that the methane hydrate was released from its frozen state down on the bottom of the ocean floor. And it literally skyrocketed. You can see examples of jets that blasted holes, big columns through the ice in the Arctic as this stuff shot skyward. The temperatures of the atmosphere increased by something like 9 to 10 degrees. And I don't honestly remember whether it was Fahrenheit or centigrade, but it was certainly enough to dramatically change the conditions for flora and fauna on the Earth, and it had a dramatic effect on life on the planet. So that's the nonlinear scary thing, and so that's why it's so important to cope with this problem. Now, when I asked Al Gore about this, he'd just written a book on carbon sequestration and other things, and he sent me off to NOAA, not the guy building New York, the National Oceanographic and Atmospheric Administration, to talk to the guy who is the world's expert on the problem of methane hydrates. And after I got to talk to him, that's when I needed a change of underwear. So I have to say that I have been blessed by access to incredibly smart people who are willing to answer naive questions. And I can't overemphasize how incredibly helpful it is to know that you can go and ask a question like that to someone who knows better than you do, and have them not say, buzz off, that's a stupid question.